Hey everybody, this is Mr. Lowry, and today we're working on this worksheet called Trigonometric Ratios. These three guys are abbreviations for sine, cosine, and tangent. If you missed today, you probably want to go back and look through the notes, print out a copy, and go through those. It will also be helpful for you to read through section 7-4 in your textbook. The math here isn't too bad, but you do need some background information before you get started. One of the things that we talked about today is what these things are. What is sine, cosine, and tangent? And they're actually just side ratios for triangles. So there's a mnemonic or a memory device to help us remember what sine, cosine, and tangent mean. And that mnemonic is kind of this nonsense word, SOHCAHTOA. Okay, what that means here, so the S stands for sine, the C stands for cosine or cos, and the T stands for tangent. Okay, the O's, the H's, and the A's are for opposite, hypotenuse, and adjacent. Okay, so in your notes today, or in the notes today, we kind of talked about this here. You can find this if you missed this today or whatever. You can find this in the notes post that's right before the assignment post here. But yeah, sine means we're going to take the opposite side and divide it by the hypotenuse, so we're going to make a ratio there. Cosine means we're going to take the adjacent side and we're going to put it over the hypotenuse. Tangent means we're going to take the opposite side and we're going to put it over the adjacent side. Okay, so that's kind of an important idea. So when we go through these here, what we're going to do, the first thing we're going to do in every single case is we're going to label everything. Okay, we're going to start with what we call the reference angle. So you'll notice here when you look at these triangles, there's a right angle every single time because we're talking about right triangles. And there's another angle measurement given. Okay, so I'm going to circle that. In this case, it's 20 degrees. So that we call the reference angle. Now what I do is I want to find all the sides in reference to that angle. So we use words like opposite and adjacent to talk about the sides in relationship to that angle. So what I'm going to do here, and I do this every single time, is I draw a line that just cuts that angle in half, just right through the middle of that angle. Okay? The reason why I do that is that line or that arrow that I drew is always going to point to the side that is opposite of that angle. Okay? So here's the angle, this 20-degree angle. This right here is the side opposite or like across from that angle. So I label it with an O. Okay, next I find the other leg. So there's two legs of a right triangle. The legs are the two sides that form the 90-degree angle. Okay. The other leg that's not the opposite side is the adjacent side. Okay, adjacent means next to. So if we're talking about this 20-degree angle right here, this side is adjacent, or it's like on the side of or next to, it's actually part of that angle. Okay, so opposite is across from, adjacent is like next to or touching. Okay, and then the side, the last side, it's not a part of the right angle. That is the hypotenuse. Okay, so O, H, and A. Okay, now from there, what we're going to do is we're going to determine which sides we have. So notice O, this opposite side, doesn't have another label, but H has a label, X, that's what I'm trying to find, and A has a label, and that's 18. So we got to look at that and see, okay, which trig ratio we're going to use. So going back to the SOHCAHTOA, we're looking for the trig ratio that uses an A and an H. Okay, so A and H is right here, and that goes with the C, so cosine. Cosine, the cosine of an angle, in this case 20 degrees, is equal to the side that is adjacent to that angle over the hypotenuse. Okay, so I use that to set up this proportion, basically. Right, so we have one ratio equals another ratio. Okay, now you might say like, okay, well, that looks like a ratio, but that doesn't look like a ratio. Well, cosine of 20 is a ratio. If you type that into your calculator, it gives you a ratio in decimal form. So on your calculator here, you'll notice that we have sine, cosine, and tangent. If I do cosine of 20, that gives me this irrational number like decimal, but really that's actually a ratio. Okay, so what we're going to do here is we're going to kind of force this to be a fraction. We're just going to put a 1 down there, because that looks more like a proportion that we know how to solve. Okay. Now to solve a proportion, one of the methods here, the methods we're going to use on this assignment is cross multiply. So I'm going to do x times the cosine of 20 is equal to 1 times 18. Okay, so x cos 20 equals 18. Now remember, I'm trying to get x by itself. Also recall that cosine of 20 is just some ugly number, right? So we're not gonna use that yet, but we're just gonna know that cosine of 20 is just some number. So if I have cosine of 20 multiplying x, what I can do is I can divide by cosine of 20 on both sides, because again, that's cosine of 20 is just some number. So x is equal to 18 divided by the cosine of 20. Okay, now that I got x by itself and I've isolated that, I can use my calculator to figure out what that is. So I'm going to do 18 divided by cosine of 20. Now notice when I use the cosine function, or if I use the sine or the tangent button, it's going to automatically open some parentheses. We just want to make sure that we close those parentheses. Okay, and when you do that, you get 19.155, etc. We're going to round to the nearest tenth at the very end of the problem, so x is about 19.2. And this little symbol, so I put equals. There's a little symbol, kind of looks like our similarity symbol. It's like an equal sign with two similarity symbols. That means approximately. Okay, so x is approximately 19.2. This is an exact answer. This is a decimal approximation. Okay. All right, now I have all those steps that we just did listed here in the notes. This is part of your notes here. One second. I got. So this is like the last page of the notes for today. So this is just showing you kind of how to do that. It looks like a lot of steps, but the first like 3 steps are just labeling steps. So a lot of these we kind of do in our head, we kind of do automatically. It looks like a kind of a long process, but it's not as long as you think. So if you're kind of having a hard time with these or whatever, use these steps in your notes to kind of help you go through it. I'm going to go through a couple more to help you out here. Okay. So again, stuff you need to know. You need to know what sine, cosine, and tangent are. Their side ratios. And you need to know that the sine is just a word that means find the ratio of opposite over hypotenuse. Cosine is a word that says find the ratio of adjacent hypotenuse. And tangent is find the ratio of opposite over adjacent. So depending on what sides I have, what sides I'm working with, will determine which of these buttons I'm going to use on my calculator, essentially. Okay, let's keep going. Take a look at number 4. So again, always start with labeling. Okay, circle the reference angle. That's the angle that's not 90 degrees. Okay, then draw a line that kind of cuts that angle in half. That line will point to the side that's opposite that angle. In this case, it's 11, this side here. So I'm going to label that O for opposite. Okay, the other leg. So here are the 2 legs. The two legs make up the right angle. Okay, the other leg is the side that's adjacent. Okay, so this side is across or opposite, cross from or opposite of 70. Okay, this guy is like part of the 70-degree angle, so we say it's adjacent to 70 degrees. This side is adjacent to 70 degrees. The other side, the third side, that's not part of the right angle is the hypotenuse. So the 2 legs are the sides that make the right angle. We label those with an A and an O, depending on which angle we're looking at. And then the other side is the hypotenuse. Okay, so that's actually here, that's just steps like 1 through 3. So find the reference angle, draw an arrow through the angle, label the sides O, A, and H for opposite, adjacent, and hypotenuse. Okay, the next thing we need to do here is we need to figure out which sides we're working with. So we have 3 labels, but we're only really interested in 11 and X. So we know O, we want A, we just got to figure out which trig ratio uses O and A. So again, there's this word, SOHCAHTOA. It's like a nonsense word, but if you can remember SOHCAHTOA, you're like, oh, tangent uses opposite and adjacent. Okay, so the trig ratio that uses opposite and adjacent is tangent. Okay, so we write the tangent of 70 degrees is equal to the side opposite of the 70-degree angle, in this case that's 11, over the side that's adjacent to the 70-degree angle. Okay, so again, we get a very similar proportion. It's just that cosine uses opposite and hypotenuse, and tangent uses opposite and adjacent. So cosine and tangent, they're just different words to say, grab me these two sides instead of grabbing me these two sides. Okay, so sine, cosine, and tangent are just telling you which two sides to put in a ratio. Okay, again, we're going to make up a little proportion here. We're going to multiply or cross multiply. So x times the tangent of 70 is equal to 1 times 11. Okay, now we want x by itself, and so if we have this number tan 70, it's just some number, multiplying x, we're going to divide both sides by tan 70 in order to get x by itself. So x is equal to 11 divided by whatever the tangent of 70 is. Okay. Now our calculator will tell us that ratio. It will tell us what the tangent of 70 is. So we can go back to our calculator now, and we can say we want the tangent, or excuse me, we want 11 divided by the tangent of 70 degrees. Okay, that's about 4.0. So we're going to say x is approximately 4.0. Okay. All right. Now you may be thinking, I don't know, maybe you're wondering, what do I do if I don't have a calculator? Well, there's lots of online calculators that you can use, and the one that I recommend you can find at Desmos, desmos.com/scientific. Okay. If you go to that website, it will pull up a scientific calculator, an online scientific calculator that has sine, cosine, and tangent on it that you can use. Okay, so you should be able to find these ratios. All right, let's keep going. Take a look at the next couple here. Okay, so we're going to start with the reference angle again. Same, the labeling is the same every single time. So there's the reference angle, that basically the other angle that's not 90 that's given. Okay, we draw a line through that angle, and that is going to point to the side that's opposite that angle. Okay, you got two legs. One of them we just labeled with an O. The other leg, remember the legs are the two sides that form the 90-degree angle. The other leg is the adjacent side. So O labels the side that's across from the 73-degree angle. A is now labeling the side that's like next to the 73-degree angle. In fact, it's part of the 70-degree angle. This side labeled X is one of the sides that makes up that angle. So those are the two legs. The other side, the third side here, that's not one of those two legs is the hypotenuse. Okay? The two legs form the 90-degree angle. The other side is the hypotenuse. Okay, so that's, again, in our little steps here. That's steps 1 through 3. Okay, now we got to figure out which trig ratio to use. Do we use sine, cosine, or tangent? Well, it depends on what we have and what we're looking for. In this case, notice that I have h and I want x. So I have the hypotenuse, I want the adjacent side. So we want the trig ratio that uses a and h again. Okay, so we go here, the SOHCAHTOA, find the a and the h. Those go with c, so we're going to use cosine here. So we set up a proportion. The cosine of angle 73, or the 73-degree angle, is equal to the adjacent side, that's the x in this case, divided by the hypotenuse, which in this case is 14. Okay, we'll put it over a 1 there so that we have a proportion. We're going to cross multiply. Notice though that in the first couple problems that we did, the x was actually on the bottom. In number 4, it was the adjacent side that was, we put opposite over adjacent. In number 2, it was the hypotenuse. So sometimes the missing piece is on the bottom of the proportion. In this case, we're using cosine, and the adjacent part goes on top. So we actually, the x is on top. That changes things just a little bit. We're still going to cross multiply. It actually makes that problem a little bit easier. In this case, we got 14 times cosine of 73 equals 1 times x. So we pretty much got x already. We don't have to divide in this case because x was on top. All we have to do is plug in 14 times cosine of 73 into our calculator. Okay, that's about 4.1. So x is approximately 4.1. Okay, so we've done a couple with cosine. We've done one with tangent. I'm gonna find. I wanted to do all the evens with you, but I actually want to find one that uses sine since we haven't done that yet. So I'm just gonna take a quick look and see if there's one that uses sine. Did I not put any signs on here? Oh, shoot. There are no... I don't think there's any that use sine on the front. That's kind of weird. A lot of cosine, a lot of tangent. That's okay. We're going to take a look at the back. There's some... See if there's any of those on the back. Okay, that's going to be a tangent. All right, cool. Number 10. Perfect. All right. So we'll skip number 8. That's okay. We'll do 10, and then we'll do one of these... multi-step problems, okay? All right, so number 10, we start with our reference angle, okay? Now you might be wondering, how did he know it was going to be sine? Just practice. Once you do this a bunch of times, you get pretty quick at identifying what you need. But let's do it together so you kind of understand how I figured that out. So we draw the line through it, right? And I notice that this is the opposite side. In terms of the angle 47, this is the side that's opposite of the 47-degree angle, okay? The other leg is the adjacent side. So that's the side that's like making the 47-degree angle with the hypotenuse. So this is the side opposite of the 47-degree angle. This is the side that's adjacent or next to or touching the 47-degree angle. And the other side that's not one of these two legs, that doesn't form the right angle, is the hypotenuse. Okay? So notice that I need to find x, which is the opposite side. I have 10, which is the hypotenuse, and so I'm looking for the trig ratio that uses O and H, opposite and hypotenuse. That's sine, right? O and H go with S. S is for sine, okay? So the sine of the 47-degree angle is equal to the side that's opposite of that 47-degree angle divided by the hypotenuse. Okay, we're going to put that sine 47 over 1 to make it a fraction, a ratio, and then we're going to cross multiply. So 10 times whatever the sine of 47 is, some decimal number, is going to equal 1 times x. So again, in this case, we don't have to do any dividing because the x was on top here. So we don't have to worry about, dividing something to get x by itself. We already got x by itself in the first go. So we're going to just type in 10 times the sine of 47, and that's going to give us about 7.3. Okay, now in these problems here, there are going to be multiple steps. You'll notice that each of these triangles has an altitude that's drawn in there, and that altitude is going to create 2 different right triangles. So let's take a look at number 12 here. I'm just going to darken this guy right here. Okay, so that kind of separates these two, this big triangle into 2 right triangles. Now we're trying to find x, right? We're trying to find this hypotenuse, and we got a 46-degree angle here. But notice we don't have either of the other 2 sides. We don't have this side or this side. So there's no way we can solve this triangle on the right until we have more information, okay? If we look at the triangle on the left, you'll notice we have a side and an angle, and so we can actually find this side and kind of solve the left triangle first, find that blue line that I just drew, and then use that guy to find x. So what we need to find what we call an intermediate value. Intermediate means like in between. So I'm going to label this line right here y. this side. We're going to call that y. So I have to find y before I can find x. That's kind of how it goes. So I'm going to kind of ignore the right triangle, or excuse me, the triangle on the right, I should say, and just kind of solve this triangle first and find y. Now what this says here is we're allowed to round our intermediate value to the nearest tenth. So usually we don't want to round before the final answer, otherwise our answer gets thrown off. But just so that we can kind of agree on what the answer is, when we find y, we're going to round that to the nearest tenth, and then we're going to use that rounded value to find x. And that's just going to help our answers to match each other. Okay, so let's start out with the triangle on the left here. Okay, we're going to start with the angle of reference, the 27-degree angle, right? Notice the degree symbol is labeling this angle. We're going to draw a line through that angle that's going to point to the opposite side. Okay, so we're just looking at this triangle right here. This is the opposite side. The other leg of that triangle, this part, sorry, this is the one of the legs. This is the other leg. The leg I labeled y is the adjacent side. So I'm going to label that A. Now sometimes it's confusing. You're like, why do you label it A and y? Well, A stands for adjacent. I'm just labeling which kind of side I want. Y is going to be the actual variable that I use. If you wanted to use A as the variable, that's fine. You can do that if you want. The side that's not forming the right angle is the hypotenuse. So when I look at what I got going on here, I got the hypotenuse and I want the adjacent. All right, I have opposite labeled, but like I don't have a variable, I don't have a number to work with, so I don't really care about O. I want to find the adjacent side, and I have the hypotenuse. So adjacent and hypotenuse, we use cosine. When we're working with the adjacent side and the hypotenuse, we use cosine. So for the first, just to solve for y here, I have the cosine of 27 equals the adjacent side, that's y. I labeled that y. If you wanted to use a there, you could, that's fine too, over the hypotenuse, which is 13. Okay, so I'm going to cross multiply here. Notice, again, they have variables on top. Sometimes it's on top, sometimes it's on the bottom, just depends. So cross multiply, I get 13 times cos 27 is equal to y times 1. So I'm going to use my calculator here. I got 13 cos 27. And that's approximately 11.6. So remember, that's what we call an intermediate value. It's not our final answer. It's like the halfway point. Now, usually, or a lot of times, we don't round halfway. In this case, the directions specifically say, hey, go ahead and do that. So if we want our answers to match the answer key, we're going to round there and then use that rounded value for the next piece. Okay. So now we have y, right? So what I'm going to do here, just because this is getting kind of messy, is I'm going to redraw this triangle, the triangle on the right. So I have this right triangle, okay, something like this. And I got this right angle, and this guy's x, and this is a 46-degree angle. Sorry, it's probably hard for you to see it. It's this guy, 46, goes right there. And then this value is about 11.6. So now that I kind of solved the triangle on the left, and I figured out that length was about 11.6, I can use that value for the triangle on the right to find x. So this is just a kind of a two-step process. Solve the right triangle, then solve the triangle on the left, and then solve the triangle on the right. Okay, so again, angle of reference, or the reference angle, 46 degrees. Draw the arrow. So this is the opposite side. The other leg that's forming the right angle is the adjacent side. And the x that I'm interested in is the hypotenuse. So again, I'm going to be using cosine here, but this time I'm trying to get the hypotenuse. So the trig ratio that uses adjacent and hypotenuse is cosine. So I'm going to set up my next proportion for the triangle on the right. So cosine of 46, that's again that angle, is equal to the side that's adjacent to the 46-degree angle, that's about 11.6, divided by the hypotenuse, which in this case we don't know. It's x. Okay, so this time, notice the two different proportions. This time the variable's on the bottom, and that's okay. It makes us use one extra step. We still cross multiply, so we got x times whatever the cosine of 46 is. Remember, that's just some irrational number, equals 1 times 11.6. Okay, now remember we're trying to get x by itself, so we need to divide by whatever is multiplying x. That number, cosine 46, we're not sure what it is yet. Doesn't really matter. We can divide it away from the x so that x is equal to 11.6 divided by whatever the cosine of 46 is. Okay, so to get our final decimal approximation, we come back in here and we do 11.6 divided by cosine of 46. And we get about 16.7. Okay, so all of these triangles here are going to be slightly different in the sense that you may not use cosine twice. You may use tangent and then sine, or you may use sine and then cosine, or you may use tangent and then cosine, or something like that. But the process is relatively similar. You have to solve the triangle on the left before you can get the triangle on the right, because the missing piece for all of these is on the right side of the triangle. The altitude that's here is going to create two different triangles, and you got to kind of find that middle piece. So use the triangle, the information given, to find the measure of the middle piece first. In this case, you're going to use cosine again. And then you can find that measurement, and you can use that one to find x. Okay, over here, you're going to be using tangent because we want this side, this opposite of 36, and this side that's adjacent to 36. So here you'll use tangent of 36 equals 18 over, whatever you want to label this, y or whatever. Solve for y, and then use that number to help you find x. Kind of same thing down here. So in 16, you're going to use sine because you want the opposite side. You want this guy, and you have the hypotenuse. So you're going to do like sine of 66 equals y over 39. Solve for y, and then once you have y, you can use sine again, because the sine of 60 should equal y over x. Okay, so just a two-step process there. You can use 12 as kind of an example. There's also two problems in the notes that you can go back to. I don't think we did these in class because we didn't have time. But if you want some examples, extra examples, you can go back to that notes post and work on these from your notes. This is 24 and 25, so you can kind of write those out for practice and then use those to help you kind of get the rest of these as well. So lots of resources to help you here. If you miss class, you're definitely going to want to go back and look at those notes. Download them or copy them or print them out. Make sure they get in your notebook. You probably need to do a little bit of extra work since you missed the lesson, so you're probably going to want to read the book, section 7-4. I'll give you the page number in Canvas in the notes section. You can go back and check. I think that will help you get there. Okay, thanks for watching, guys, and I'll talk to you soon.